This is a video from Math 386. It's on assignment 5. Let's take a look at problem 17. It says, find the dimensions of a rectangle with area 1,000 square meters whose perimeter is as small as possible. Okay, so we have a rectangle. So let's draw a picture of a rectangle. And what I'm going to do is I'm going to let x equal the width of the rectangle, because we don't know what that is, and let y be the length of rectangle. Both x and y are in meters, right? So I'm going to let x be here and y be here. Now, one thing we want to note is that x and y have to be greater than or equal to 0. In fact, we could even claim that x and y have to be strictly greater than 0. Because if x or y is 0, then there's no way you're getting an area of 1,000 square meters. Okay, now, this is how the template needs to look, right? What are we trying to minimize? We're trying to minimize perimeter, which is equal to 2x plus 2y. What's the constraint? Okay, so in other words, how does x relate to y? So we can say x times y equals 1,000. Now, solving for y, we get y equals 1,000 divided by x. Therefore, p of x, right? So I'm going to take what I'm trying to minimize and restrict it or condense it to a function of one variable. So this is 2x plus 2 times 1,000 over x, which is equal to 2x plus 2,000, right? Because that's what 2 times 1,000 is, x to the negative 1. So take the derivative. P prime of x is 2 times 1 plus 2,000 times negative 1x raised to the negative 2, which is equal to 2 minus 2,000 divided by x squared. From here, set p prime of x equal to 0. So 2 minus 2,000 over x squared equals 0. So 2 over 1 is 2,000 divided by x squared. Now, can we see that I can cross multiply? And when I do, I get 2x squared equals 2,000. Dividing both sides by 2, we get x squared equals 1,000. So therefore, x is the square root of 1,000, which is the square root of 100 times 10. But the square root of 100 is 10. And so x is 10 times the square root of 10. So 10 square root of 10 times y is 1,000. If I divide both sides by 10, I get square root of 10 times y equals 100. Now I'm going to do it one more time, and I'm going to say y is 100 over square root of 10. But if I multiply the denominator and the numerator by square root of 10, I can say y equals 10 times the square root of 10. So the width is 10 times the square root of 10 meters. the length is 10 times the square root of 10 meters. And that's how we do problem number 17. Problem number 18. So the sum of two positive numbers is 16. Okay? The question says, what is the smallest possible value of the sum of their squares? So what I'm going to do is I'm going to let x and y be the numbers, because we don't know what they are. And you have to identify your unknowns. You know, word problems don't mean anything if we don't know what our unknowns are. Okay? Now, these are positive numbers. So one thing to note is that x and y are positive. So we want to minimize and we'll call it sum, or, S for sum, which is x squared plus y squared, right? So the constraint. So in other words, how does x relate to y? Doesn't sum mean add? So x plus y equals 16 is equals. So y is negative x plus 16. So now, S evaluated at x is x squared plus, and I'm going to replace y with negative x plus 16. And I'm going to square it. Okay. So this is x squared plus x squared minus 32x plus 256, which is 2x squared minus 32x plus 256. Take the derivative. I have to see a derivative with these optimization problems now. So I'm going to get 2 times 2x minus 32 times 1. And that's 4x minus 32. So I'm going to set the derivative equal to 0. So that says 4x minus 32 equals 0. So 4x equals 32. And when I solve, I get x equals 8. Now, if x is 8, y is negative 8 plus 16, which is 8. So the numbers are 8 and 8. And that's how we do problem 18. And that'll do it for this video. And this is on assignment 5, Math 386. And we looked at problems 17 and 18. Thank you.